Hello students, welcome. Previously, lesson 7, form 4, topic 4, we were dealing with the mixed concept on the uses of the standard electrode potentials. So today, lesson 8, we are going to still on the electrochemical cells, and we are going to see the applications of the electrochemical cells or the voltaic or galvanic cells. And we're saying the redox reactions in an electrochemical cell or voltaic cell or galvanic cell is commercially applied to make the following. Part A, to make dry cells, which is also known as primary cells. So a good example of dry cell or primary cell is the Leclerc cell. So part B, we are going to do also wet cells, secondary cells, and a good example of the secondary cell that we are going to pick is the lead acid accumulators. Then part C, we are also going to do fuel cells, and the good example that we are going to pick from the fuel cells is the hydrogen oxygen cell. So I say each of these cells will be explained in details. So today our class will be only the dry cells. So in our next class we are going to do the wet cells or the secondary cells or the accumulators. So we're saying dry cells, they're also known as primary cells. An example of a dry cell is the Leclerc cell, and this is how the Leclerc cell look like, or a dry cell. So we're having the brass cap here, this one is the cap there, then we're having the sealing material there, we're having the graphite rod which is acting the positive terminal, it is there. Then we're having the zinc out casing, that is the negative terminal that we are going to use. The zinc out casing can be called the zinc cane, or we can say it's called zinc container. All of those ones we can give it. So next we are having ammonium chloride and also zinc chloride, which is in form of a base. Then next here we are having bonded carbon and also manganese peroxide. So learners, we are supposed to have or know the roles of the bonded carbon and also manganese peroxide. So we are going to discuss it down there. Kindly note that. So we're saying dry cells consist of a zinc cane, that's the zinc casing that we are talking about, containing a graphite rod at the center, and we have seen the graphite rod was this one, which was acting the positive terminal, surrounded by a mixture of ammonium chloride and also zinc chloride based, and we were having that one here. So I say the zinc cane or the zinc container acts as the negative terminal because it is the graphite rod which was acting the positive terminal. So also acts as the anode where it gets oxidized. That means where oxidation reaction occur. Remember when we are defining anode, we said anode is the electrode where oxidation occurs, or where oxidation reaction occur. So what is oxidation? Oxidation is loss of electrons. So we have in zinc solid losing electrons to form zinc 2 ions. So electrons lost are written on the product side or are written on the right hand side of the ionic equation. So what is the role of the bonded carbon? This bonded carbon, we're saying the bonded carbon increases the surface area of the positive terminal. Which positive terminal? The graphite rod. That's what we're talking about. So let us go next. We're saying the graphite rod acts as the cathode where it gets reduced. What does that mean? Where reduction reaction occurs. So what is cathode? We said cathode is the electrode where reduction occurs or reduction reaction occurs. And we're saying a mixture of ammonium chloride and also zinc chloride based acts as the electrolyte. So our electrolyte there is the base. Ammonium ion from ammonium chloride at the positive terminal, that's the cathode, are converted to ammonia and also hydrogen gases. So this is the question. We are having 2 moles of ammonium ion aqueous gaining 2 electrons lost from the anode by the zinc. Then we are going to form 2 moles of ammonia gas and also 1 mole of hydrogen gas. We are saying the gases produced do not escape but are immediately used up in other reactions. So that means none of these products are going to escape. So we start with manganese peroxide. Remember, manganese peroxide, we have seen it here in the lattice cell. We are having a mixture of bonded carbon and also manganese peroxide. We have seen the role of the bonded carbon. We said it increases the surface area for the positive terminal or the surface area for the graphite rod. So what about the role of the manganese peroxide? And here we are saying manganese peroxide oxidizes the hydrogen gas produced. This hydrogen gas produced at the electrodes to water, therefore preventing any bubbles from coating the carbon terminal. What does that mean? The carbon rod. That's what we are talking about, which will reduce the efficiency of the cell. So once the terminal or that carbon terminal is coated, that means it will make the cell not to function well. So next we are saying ammonia gas forms a complex compound with the zinc chloride in the base. What does that mean? Ammonia gas reacts with the zinc 2 ion and zinc chloride to form a compound called tetraamine zinc 2 ion, which is a complex compound or complex ion. So next we are saying ammonium chloride is used as a beast. As a beast. Why? Why are we using it as a beast? We are saying because dry ammonium chloride does not conduct electricity because the ions are not mobile. So the way you see ammonium chloride is composed of ammonium ion, which are positively charged ions, and also chloride ions, which are negatively charged ions. So the type of compound which is having positively charged ions is called ionic compounds or ionic substances. And when we were learning the physical properties of ionic substances, we said ionic substances do not conduct heat and electricity in the solid phase. Why? Because the ions forming the structure are not mobile, but they just occupy a fixed position within the structure. And we said if they are melted or when they are in solution form, they will conduct heat and electricity because the ions forming the structure are mobile. So we're saying the dry cell or a simple dry cell can produce a potential of 1.5 volts. So we're saying the cell representation for the cell is shown below. Remember when we are writing the cell representation, which is also known as the cell notation or the cell diagram, we said first of all we have to write the half cell for the anode side or where the oxidation reaction occurs. So here we have the zinc rod, which is in solid form, and here this vertical slash is the phase boundary or vertical line. It's the phase boundary, which is solution form. Then we're having two vertical lines which represent the salt bridge. And remember, we have seen the roles of the salt bridge. We said it completes the segment by connecting the two half cells or by connecting the two solutions. So next we are having ammonium ion, which is aqueous. We have the phase boundary, and we are going to have ammonia gas plus hydrogen gas. And the standard electrode potential for this cell is 1.5 volts. So next we are saying since the reactants are used up, the dry cell or Bremer cell or Leclerc cell cannot provide continuous supply of electricity. So that means once it's used, it cannot be recharged or it cannot be reused. So once it cannot be reused, it will be discarded. It will be discarded. And we are saying the process of restoring the reactants is called recharging. So once the cell is not able to be recharged, it will be discarded. So let's go and see advantages and disadvantages of using dry cells. So advantages, we say number one, it is cheap. That means it is affordable. So number two, it is convenient to use. So that means it is easy to use because it contains the electrolyte in form of a paste rather than a liquid. Therefore, it cannot spill or leak. Then we got the disadvantage of using dry cells. So number one, we are saying they cannot be recharged. So once it is energy or it is reactants are used up, it cannot be recharged. That means it cannot be reused. That's what we can say. It cannot be reused. Cannot be reused. What does that mean? When it's used, it will be just discarded. So number two, the other disadvantage is we are told they produce less potentials compared to the other cells. We got C, use of dry cells or the uses of a dry cell. We are saying number one, used in a wide range of electrical appliances such as radio, watches, clocks, flashlights, and also electric bells. And then we are going to have extended questions. Learners, you are supposed to attempt this question, and all the questions that they're asking us, we have already discussed in this lesson today. So you're told, question 1, the diagram shown below is a longitudinal section of a dry cell. Study it and answer the questions that follow. So this is a dry cell or like ledger cell. We have said all these parts. We are going to go straight to the question. Then we are told number one, give two rolls of the zinc out casing. So that zinc can or zinc container has two rolls. So you are supposed to use the notes to find out the two rolls of the zinc container or zinc out casing. Then part B, we are told write down the question for the oxidation reaction. Then part C, we are saying explain why the outer casing softens as a dry battery is used. So we're saying part D, why is ammonium chloride used as a base rather than a solid or a dry solid? So all of these questions, we have discussed it, the notes in this lesson. Try to find the respective or the corresponding answers, and you can just submit or share your response and your answers in the comment section. That's the end of our lesson. Thank you for watching.